Have you ever wondered what power a small smartwatch holds and how many sensors are packed in such a tiny device? Today, I will take you through my experience with one of the most powerful ones, the accelerometer. My name is Gosia, and I'm both developer and a cyclist. I've been creating mobile apps for 5 years, and I've been riding bikes professionally almost half of my life. In this presentation, I will tell you about 3 things. First, a bit more about my cycling passion. Second, about things that inspired me to create an application that can be used to analyze and improve particular cycling technique. Lastly, how I implemented my app concept. And by the way, this is my very first presentation for such big audience, so thank you for your support. Let me start by telling you a bit more about my passion for cycling. Most of my career, I did mountain biking. However, a few years ago, I found a new love, cyclocross. In this discipline, I'm more successful. I've been just off the podium in national championships twice, and I've been several times in top 10 of big international competitions. This is cyclocross, very special discipline. It takes place in autumn and winter, hence, during races it's frequently cold and rainy. It's very entertaining and intensive. Races are short, last approximately an hour, laps are fast and not very hilly. There are numerous obstacles, it's quite technical, and many times you need to dismount your bike and run. I especially love it because it's very competitive. Time differences are small, and you fight back to back for every place. Regardless of it all, I soon realized that I'm not physically the strongest competitor, so I thought to take advantage of my technical skills. In cyclocross, it's crucial to be fit, but also have great handling skills, especially while taking turns, which in cycling world is called cornering. Why is cornering so important? To help you understand it, there is a short clip. It shows my favorite, one of the flattest but also very technical track, from bird's eye view. In cyclocross, there are tens of turns on each lap, which means that during the races, I usually have to employ cornering technique around 100 times. Let me explain why it's so hard to master taking turns. Cornering skill has 4 components. First, we need to be able to assess corner. We have to consider how sharp is turn, but also corner profile. The angle of turn is called camber, and in most cases it's positive. However, in cyclocross, it's quite popular to add off-camber section as an obstacle. Off-camber provides less grip, and it's harder to ride with high speed. In contrast to cyclocross, track racing is very different. Track is built in a way that allows rider to keep very high speed without need of slowing down. As an off-road rider, it's important to take surface into account. Mud and gravel are slick, so when approaching turn, you need to choose your speed wisely and avoid braking inside of the corners, especially if you don't want to end up eating grit. Like my husband. Don't tell him I put his photo there. He doesn't know. Another important component is cornering technique. The faster you go, the more you need to tilt to the center of the turn. Since cycling is all about being fast, this technique is very useful because it's simply not possible to turn your handlebar using handlebar at high speed. When you have all 3 nailed, here comes the trajectory. Trajectory is about choosing optimal line To keep highest speed and traction, there is one rule. When approaching the corner, one needs to start wide, then cut in the middle and leave wide again. My idea was to find a way of measuring and improving speed in particular corner. Those four components combined makes cornering technique demanding, but it's possible to find pattern for best performance. Two things helped me to find solution for the challenge I wanted to solve. My first inspiration was taken from motorbikes, as it's very similar from physics perspective. As when riding bikes, while taking turns, rider needs to lean to the center of the bend. In motorbikes, there are also sensors to measure motorbike tilt angle, which is called bank angle. It's used for safety purposes, turning off engine when vehicle fall over. I took another inspiration from aircraft. There are three ways of describing position of plane in the air. For me, the most important is rho. It describes angle of inclination from the center of gravity, which is also called bank angle as for motorbikes. Pitch is about elevating and dropping altitude. It's calculated as an angle from nose to the center of gravity. Yaw is the trickiest one and describes machine rotation. Positive yaw moves the nose of the plane to the right. Being a developer by profession, I thought that I could perhaps create an application for my smartwatch. I had an idea that using a sensor, I would be able to measure tilt of the bike while cornering, and therefore help to improve overall speed. In this way, I could have better results just by having a better technique. To achieve my goal, I decided to use my Garmin smartwatch. Phone is not very handy, and depending on the device, sensors are rather less accurate. It's also less resistant to mud and water. All I needed was to use accelerometer inside my application. Accelerometer is simply the device that measures acceleration. Garmin requires accelerometer for many features, like emergency detection, turning on backlight while picking on watch, or calculating distance indoor. I found out that I can use rho in my application to get angle in degrees. However, rho is mirrored value of what I wanted, so I needed to do some additional calculations. To start writing code, I needed to dig into SDK documentation. Garmin has its own language, Monkey C. Monkey C derives from other popular languages, and Garmin claims that it's a language that you never know that you already know. To me, it actually felt like writing Android app in a mix of Java, Ruby, and JavaScript. My idea was to get accurate data from watch and then visualize them in my React Native application. That could help me to analyze how my cornering skills are correlating with speed. At the start, I thought that I could connect my phone and watch using Bluetooth. When I searched for the documentation, I found out that it's simply not possible, and Garmin has its own way to do it. Actually, it turned out that watch and phone are talking to each other via messages. It can be two-way communication, but for me, sending messages from watch to phone was just enough. It's easy to implement, but has some disadvantages. You need to stay connected with internet, because Garmin sends messages through their cloud services, so it would not be very handy in area with poor network coverage. Due to this, I also experienced a lag when receiving a message. Let me quickly discuss the solution schema. First, I focused on creating app for watch. In this part, I handled reading sensors values and calculating data. Second, to connect Garmin and React Native app, I needed to use Android library provided by Garmin. I couldn't find any ready-made solution for it, so I decided to take advantage of my skills and prepare native module myself. Finally, utilizing native module that I created, I was able to receive and process data sent by Garmin. I know you've been waiting for this moment for long, so here comes the coding part. First, I will cover implementation of Garmin application. There were 3 steps to get things done. First, I registered callback to get sensors data. Second, prepared receive data. And lastly, send them via message. To get data from sensors, I needed to first add import for sensors package. Second, create configuration to specify what data I'm interested in. Lastly, I could pass callback and configuration to Garmin functions that allows to listen for sensors data updates. In callback, I got all the data that I requested in configuration. For me, the easiest way was to use row and calculate bank angle using it. Sending messages requires importing Garmin communications package. Then, I'm creating payload with all the data. Finally, sending it with transmit function. So, we've got Garmin part done. Time to see how it works. I had plenty of space to test my application in backyard. Working with sensors includes some real-time testing. Some parts of application could be developed on emulator, but not getting sensors data. It's laborious, but gives great deal of satisfaction. Let's move on to second step. My native modules leverages Garmin Connect library and calls native Android functions. It allows to get all my Garmin devices, connect to a web one, and register a listener for receiving messages. Before we move on to implementation, I want you to understand one thing. Getting data from Garmin Smartwatch requires connecting both devices. Using Garmin SDK, I'm able to get info about every device that is added to my account. Inside my application, I'm using 3 statuses of Garmin devices. Device is offline when it's not in range, but it's registered inside Garmin Connect application. Device that is reachable and ready to connect is online. After clicking list on online device, it's becoming connected. Let's dive into implementation of preparing devices lists. First, I'm getting known and connected devices using library provided by Garmin. Then, looping through known devices. In order to get device status, I'm checking whether it exists on Connect Devices list. With that, I can put name and status into map and push it to device array. And since it is written for all architecture, I'm resolving promise with ready devices list. Next one is connecting the device. I decided to use name for connecting purposes because it's always unique, and I can use it to find a selected device in devices list. Then, all I need to do was to register for receiving messages. Moving on to handling messages, Garmin library shares many interfaces for getting wide range of updates. One of the event listeners allows to override on message received function and get messages from Garmin device. Here I'm reading payload and converting into JSON for easier use in JavaScript-based application. Then creating message and sending it using device event emitter. With native module done, let's cover React Native app. First step is crucial to process and analyze recorded data. React Native application is utilizing native module to show, let user connect to the device, eventually handle and process incoming messages. Starting with the devices lists, I use hooks to split parts of code and make components cleaner. Getting devices list is pretty simple. It's only about using async function from native module and saving result in state. Next, it's time to connect phone and Garmin smartwatch. Connecting device is also asynchronous, but this time I used listeners from device event emitter. With that, I could keep track of every change to device status, whether it's connected or disconnected. Finally, we can listen for incoming messages. Here, I also needed to register a callback to device event emitter. When I get message, value is saved to local database for further usage. Time to put all that into practice. I placed my watch on handlebar next to the computer that is recording whole session. Proper measurements requires this placement, as it's important to calculate angle from proper axis. Additionally, I need to counter bike tilt with body to not fall over when too much weight is put to the side. The video you are seeing now presents my technical lab, so it gave opportunity to test things out in real life. I just needed to avoid trees since the path is tightly surrounded by them. Now, we can analyze technical section I just wrote. So here you can see app interface. Chart on the top represents bank angle in red and speed in orange. At the bottom, you can see the track, and picking particular location shows the values in tooltips. Looking at bad angle is very important, but its true purpose is to maintain speed. The key is to not lose momentum while taking turns, and it's what cornering technique is for. Ideally, there should not be much speed drop while taking wider corners, which means speed line should be as flat as possible. So, yet again, I did testing in my backyard. This time, I focused on increasing speed and bank angle until I couldn't improve anymore. I started from smallest angle I was able to keep, just to show you the difference. It's been a long way to get there, and I'm happy with the progress I've made. Being a developer gives way to enhance world in a way that only our creativity restricts us. We can create things that allow us to solve complex problems and make processes easier. At the same time, cyclists are very focused on numbers. We measure everything, starting from time at Strava segments, ending on long distances, and max speed. Combining my two passions, I was able to create a tool for measuring yet another component, which results in improvement of my final performance. Now, I can use my application during technical trainings and see whether I'm improving and how fast I can take turns without crashing. As soon as my season starts, I will be able to record and analyze lab to see where I can push myself to the limits and see what parts requires more trainings. If you are interested in whole code base, it's free to grab on my GitHub. Feel free to inspire yourself for creating something useful for your smartwatch, as I did. If you have some questions, you can find me around in person, or feel free to reach out to me via email or Expensify app. You can also find me on Instagram, where I share updates from my cycling world. Now, I'm ready to kick off my season in 2 weeks. Huge kudos to Callstack team that helped me to prepare this presentation. And many thanks to my mentor Dratva for inspiring me to create Garmin application. Thank you for your attention and have a great time at conference.